Hello everyone, in this video we're going to be solving a geometry puzzle. Two circles are inscribed in a 3, 4, 5 triangle as shown. Find the radius of the purple circle, the one that's been shaded. At this point you may want to pause the video and try this problem yourself first. Okay, so we do have two circles that are inscribed, and this is a special triangle 3, 4, 5. The height is 5, the height is 4 and the base is 3, hypotenuse is 5. Okay, so it's a right triangle, which is good. So I'm going to start by finding the radius of the green circle first. As you know, this is the inscribed circle, which you can call in circle, and we can totally ignore the purple for now. Okay, let's go ahead and do the following. I'm going to make some connections here, and let me make sure that I have the right ink. Okay. Here we go. This connection and this connection obviously is going to help us because, as you know, especially in a right triangle, if you consider the in circle, you're going to find a lot of interesting things because what's going to happen is that you get a little square here in the corner, right? So that's kind of nice. Okay, let's go ahead and connect these two pieces as well. So like this way. Okay, now how does this help us? Well, we do know that these are the radii, and let's call this x because we're not actually looking for x, we're looking for r, which is the radius of the purple circle. Now, what do I know about this? Well, this is also x, this is also x. Well, since the base is 3, then this length would be 3 minus x, but we know that these pieces are the same length, so this is also 3 minus x. Nice. Now again, ignore the purple circle and consider the whole length here. Well, we know that if this is x, this is going to be 4 minus x, and this is going to be 4 minus x. Well, this is interesting because we know that the hypotenuse is 5, so the sum of these two pieces is going to equal 5. Let's go ahead and do that to find x. 4 minus x plus 3 minus x should equal 5, which means 7 minus 2x is equal to 5. From here, 2x is equal to 2, which means x is equal to 1. So we know that x equals 1. The radius of the green circle. Now we're going to use that to find the radius of the purple one, which is r. So let's go ahead and make more connections here. I'm going to change the color so that we don't get confused with all these lines. So let's go ahead and make a blue connection here. And then what else is going to be helpful here? If you go ahead and connect this here, like this way, and obviously, we can just make a perpendicular segment here like this one. Okay, so this is pretty much what we need. Okay, so now since the radius of this circle is called r and the whole thing is x, the remaining piece is going to be x minus r here, and this is going to be r. Okay, awesome. What about this one? Well, this is r, this is x, so the hypotenuse is going to be r plus x. Awesome. Then I can find this height, right? This length. But let's call this h, this part. What happens if you call that h? Then we know that the whole thing is actually, and we know that x is equal to 1, right? So, okay, that's good. So if you take out 1 from the 4 minus 1 is going to be 3. So this part is going to be 3. If you take out the h, this is going to be 3 minus h. Okay? 3 minus h here. Awesome. So now I do have two triangles. Oopsies. So I gotta back up a little bit. Okay. So this triangle and this triangle. What's so special about those triangles? Well, they are similar. Awesome. And we know the lengths. So let's go ahead and write some similarity relationships for those triangles. Well, first of all, I know that the corresponding side lengths are going to be like h to 3 minus h, right? For the heights. And then that ratio is the same as the ratio of the bases, but the bases are r and x minus r, but we do know what x is, right? So we can just go ahead and replace x with 1 here. So it's going to give us, let's go ahead and do the following first. hx minus hr is equal to 3r minus hr. Cool. Then we can just go ahead and simplify hr, and we get hx equals 3r, but if you replace x with 1 here, you'll get h is equal to 3r. Awesome. So we now know that the height of this triangle is actually going to be 3 times the radius of the smaller circle. Cool. Now what else do we need? Well, we still need another equation to calculate what we're looking for, right? So what are we gonna do to find that? Well, we do have this triangle here, right? And we know that the height is 3 minus h, the base is x minus r, which I can write in terms of r, because I know x, and then the hypotenuse is r plus x. Again, we can do it. Okay, so I'm going to be using the Pythagorean theorem on that triangle. So I'm going to be writing something like 3 minus h squared plus x minus r squared is equal to the hypotenuse, which is x plus r squared. Awesome. And here, again, we're going to be using our identity. If we isolate 3 minus h squared, then we're going to be getting x plus r squared minus x minus r squared. As you know, that's always equal to 4xr. Since x is equal to 1, this is going to equal 4r. Now, I was able to get another equation in terms of giving a relationship between h and r. So now what I can do is I can go ahead and use this substitution here, right? I can replace the h with 3r. That'll be helpful because what I'm looking for is actually r. So I can now set it equal to 4r. Now, nice. This is pretty because now we have an equation in r only, and we're looking for r, which is the radius of the purple circle here. All right. So we're going to be solving for r here, but this is quadratic. Let's go ahead and expand it. 9 minus 18r plus 9r squared, right, to ab is equal to 4r. And then we're going to put everything on the same side. 9r squared minus 22r plus 9 is equal to 0. Okay, so at this point, what we need to do is we need to solve this quadratic equation. And how are we going to solve that? We're basically just going to use the quadratic formula, right? I mean, there are so many ways to do this, but just one of the methods that you can use is quadratic formula. And is this factorable, by the way? No, because it's going to have irrational root. Let me just tell you that. So don't try to factor it. And you can check that with the discriminant, right? If the discriminant is a nice number, then it is factorable. Okay, let's go ahead and proceed. Let's set up the quadratic equation. So r is going to equal from here negative b plus minus, and about the plus minus we're going to decide in a little bit which one is good. Square root of b squared. Okay, what is 22 squared? I'm going to need to find that, minus 4ac. Now, if you calculate 4ac, you're going to get 36 times 9 or 81 times 4, which is 324. Okay, all over 2a, which is 18. Let's go ahead and simplify this a little bit. R is equal to 22 plus minus the square root of 22 squared. Okay, so 22 squared is going to be 484, right? If you subtract 484 minus 324, that's going to be 160. Okay, and that's going to give us a somewhat nice answer because the square root of 160 can be written as 4 root 10, right? 4 root 10 divided by 18. And if I go ahead and simplify this, how can I simplify this? Well, I can just go ahead and divide everything by 2. That's going to give me 11 plus minus 2 root 10 divided by 9. Now, at this point, I'm going to go ahead and split this up into 2 solutions, and we're going to decide which one is appropriate. Okay. All right. Awesome. Now, square root of 10 is a little over 3. Let's say it's 3. So this is going to be about 6. 11 plus 6 is 17. 17 divided by 9 is close to 2, right? This is pretty close to 2. Now, that was 17. So 11 plus 6. 11 minus 6 is going to be like 5-ish, right? 5 divided by 9 is going to be close to 1/2. Okay. So we're going to decide which one is closer to our answer. If you look at this picture here, you notice that we know that x is equal to 1, so r needs to be less than 1, right? Obviously, it's a smaller circle, so which means that we're going to go with the second solution. So this is our radius. Thank you for watching. I hope you enjoyed the video. This could be considered an easier puzzle, I think, compared to other ones. Please comment, like, and subscribe, and see you in the next one. Bye-bye.